As Susanna introduced me before, I'm a machine learning engineer at Bespoke, and I'm also doing some community work with MLT as well. And so you may have seen me at some of the other events or something. So today, just as Max had mentioned before with his talk, that we'll be working on a retrieval-based chatbot, where we already know what the answers are predefined. We're not going to be changing them. We're just going to look them up from a database, and we'll work on this intent classification bit where we just want to understand what the user has told us and retrieve the correct answer. So to get started, I'll share the GitHub page link here so that everyone can follow along. Right there. I'll just post this on the chat. Oops. And I'll post this on the slide as well. So see. Let us know in the chat, in the Slack channel, or in the chats if you can't find the notebook. And the channel on Slack is MLT Workshops. So you want to join that channel and you can participate in the discussions. Thank you, Susanna, for posting that. To start off, I also want to say that the workshop will be very much hands-on. So the goal or the expectation is that we'll build our own data sets, go through them, go through this code using our own small built data sets and build our own flavor of chatbot. And we'll be using, so if you're following along with me, if you're an expert, you probably know how to use Jupyter or something to run this notebook. But if you just want to follow along with me, we recommend using Collab because it has all the environment and everything built up. So and it also allows you to use GPUs because we'll be training a small model, but it'll be faster with the GPU. So it'll be easier to follow along if you do that. If you haven't used Collab before, you need a Gmail account because Collab works from your Google Drive. So I'll quickly go through the steps of accessing Collab. There's instructions in the doc and in the notebook as well, but I'll go through them with you. So if you click on the welcome page link, it'll take you to this pop-up. And here, if you go to GitHub and paste this URL, which has the notebook, and it'll show you this path, and that's the notebook we'll be following. So that'll allow you to open it in Collab. So once you have it opened, what you want to do is you want to save a copy in Drive, because if you don't save it in your Drive, you can't edit the file. And then finally, we want to select the runtime. We want to specify that we want to use the GPU. I'll do that again. Run that a bit fast, maybe. Click on runtime, change runtime type, and select GPU, and then click save. So that's it. We're ready to get started with that. Okay. So the first step, we'll have to install a few dependencies. And what you want to do is you want to comment out this line here. That'll let you download the file from our repository and then install the right dependencies here.
Here, someone is asking if you could zoom in a little bit to see the
Okay,
code.
right.
Thank you.
Is that better?
Yeah, that looks better. Thanks.
All right. Okay, so that will take a couple of seconds to run. So once you've installed this, it'll say you must restart the runtime in order to use the new Exxon version. So that'll just restart the kernel. So now it can use the right packages that it downloaded right now. Right. So then the first task for this workshop will be creating your own corpus. And I'll show you a small sample of what that corpus might look like. It doesn't have to be anything too complicated. And as you noticed in the last talk, we just have one label and a bunch of phrases that represent that label. So for example, you can have a dictionary with training phrases, and your key is the intent label, and for us, it's when it's check-in, and then you have a bunch of phrases after that as training data describing what is check-in. Similarly with the other ones, and we'll have another one for answers. We don't need a bunch of those for that. We just need just one answer, and I just arbitrarily wrote an answer here. So I have created a small data set for us to use during the workshop, but please create your own and make your own ones. And we'll have a little bit of time right now so people can work on this. Anything very simple is fine, like 5, 6, and 10s. You don't need that many. But I'll show you what the format should look like. So I guess people can see the JSON file. Okay, I'll make it slightly bigger here. Okay. So I have some metadata here. You don't really need that. But it's just saying, okay, so there's the intent, one dictionary with the intent, and then you have a bunch of patterns describing what those intents are. You actually don't need this many. Like 5 to somewhere between 10 and 15 per intent is good enough. And if you have like 5, 6 intents, that should be enough for us to play along with during the workshop. So with that, we'll get to the first practical bit of the workshop. And so I'll give people some time to work on this, and we'll be back in 10 minutes. And pick like any industry. It doesn't have to be hotels as well. You can pick the airline industry, or you can pick restaurant reservation system, anything that you're interested in. And while we're doing that, I'll take a look at the questions and see if there is any issues popping up. Are there any questions to share that I need to address?
In Zoom, we have 2 questions. Do we need to create a JSON file? Does it have to be in JSON format, or can it be directly in the cell?
Oh yeah, no, it doesn't. You can beat the cell as well. So you can just do, I'll just copy this bit, something like that. And you have intent 1. Then patterns. That. if you like. Something like that, yeah. Or actually, you don't even need this part. Just something with intent and patterns with a list of different phrases should be good enough. And if you do that, you can just skip the JSON load and directly use it, whatever format you have. Okay, I think we'll get we'll move on with the next part. There's no rush, so you can come back to it. As I said, we'll have some of these smaller tasks throughout, so you can add more data. And we'll have a small break in between, so you can work on your data set during that time as well. So we have our data set prepared now. Oops. And so for me, I had put everything in a JSON file, so I'm just gonna load it and take a look at the labels. So, okay, so I have 5 intents, checkout, check-in, is there early check-in, late checkout, and where's the front desk located? So very fairly simple queries that anyone at like a hotel lobby might want to ask at the reception desk or something. And I have my answers, and I've just hard-coded them, picked a random time, whatever, and it'll always return that answer no matter how many variations you have to your query. So once we have this, it's like pretty, this is like more about software development than it is maybe about machine learning in general or the chatbot part, but it's good to have a data structure to put your data in instead of always looking up from a JSON file. I want to put them in like a nice object. For my case, like, okay, it was JSON. I wanted to do some kind of pre-processing steps to it, and then have it together. And it kind of gets messy if you keep adding or removing the same from the same JSON file again and again, and sorry, I'm getting some chats. Yeah, just keep iterating on the same JSON file. So it can get pretty messy. So I just put it in a nice class, and in the init, I'm just looking through the objects and the fields in the JSON. I'm making everything the patterns lowercase. I'm removing all punctuations. It's like a small regex here that takes care of that, and then just adding patterns to it. And I'm also making another one for answers. And finally, when I'm done with all of that, I put it in a nice pandas data frame, and that's it. Basically, I'm done. With the object, I also get to add like nice functions that I can access things right away. I mean, of course, you can access the data frame itself and get these, but that can get messy and you may have to do it again and again. Also, this allows us to customize whatever kind of way we want. So it's just good practice to have it in a data structure like this. So once we get that, we can just pass in. So I'm passing in training data, which is the JSON file that we loaded. Patterns is the field where it should look for the phrases for every intent, and answers is what I had defined here. So it's just labeled in the same way: intent, answer, pair, dictionary, like that. So, okay. Okay, so that looks good. I also added this like show batch. It's not really a batch. It's just looking at the data set. So it allows us to look at what we just loaded into a object. So just look at the first 10, see what it looks like. Okay, intent, the phrase is when is check-in, answer. Okay, so that looks accurate. And I have around 368 data points in my data set. So first step is what we will do, the rule-based intent classification. Well, it's not really classification, we're doing matching. So as we had seen in Max's pipeline, so the first step is just string matching, so you can do it right away. And it's very fast. It's always going to be accurate. and there's like no cost to do it, so why not, right? So define a exact match function, look at all the intents, get the phrases, and if there's a match, return the answer. And I added this special phrase unknown. So if none of these match, then return the unknown token or the unknown phrase. Like I don't know what it is. So we have that written. And we do okay. Is there early check-in? Oh, okay, great. There was a match found, and it predicted the right, or well, looked up the right answer. Oh, and I just noticed my video has been off this whole time. Okay. So let's try another query. When do I check in? Okay, check-in is at 3 p.m. So that seems to work as well. But what happens when we try something complicated? And I know this is complicated because there wasn't a pattern like this in my data set. So okay, it turns out that's not great because the words check-in are clearly in there. We should be able to find out what that is and look it up and return the right answer. And also, you'll notice the exact match, even with the same query, if I add a bunch of punctuations like that, it returns I don't know. So that's also not great. So definitely there are many limitations to this. So then we can add some pre-processing steps. I've outlined a few that you might want to do. These are some things that usually come up. So like other language characters, like Chinese, Japanese, or Korean characters. This is something that comes up in our system a lot too. Normalizing contractions, so going from didn't to did not, those kinds of things. Maybe in your data set you have a lot of did not, but none didn't, so you want to normalize that in some way, or the reverse, depending on how you designed your data set. Hyphens, stop words. Stop words are basically, if you're familiar with NLP, stop words are a and the type of things that come up often in language, but don't provide too much value on the meaning of the language. Typos, Max had mentioned that in his talk as well. Plurals, they also don't provide much value for intent classification, at least for depending on what the use case, but most cases probably doesn't. ASCII, so you might have accented characters like cafe with the C with a little dot on top. You might have those and maybe not in your data set. So if you normalize some of these things out, then you can easily do a much better exact match, right? And we just did the removing punctuation during the data cleanup part as well. So I'll show a couple of, I won't cover all of these. I'll show a couple. The first one I'll show is how to do emojis. So you can get, maybe this is something that's recognized easily and it's a Unicode character. But if your user inputs this, probably maybe you may not be able to classify that properly. So we just write something to map those one onto the other from just regular characters to their Unicode equivalent ones. And we write a regular expression that catches all emojis within that Unicode range. So normalize is it's changing the mapping basically. So if you find this, replace it with this because this exists in our data set and this one does not. And then isolate. So maybe we don't want to, if they're close together. So for example, so if the user types in like that, and they're pretty close together, that can be hard depending on what kind of tokenizer you use. And we'll get to tokenization too. So you just want to split that and make it separate so that it's easier to tokenize it and classify it properly too. So that's what the isolate emoji is doing. Similar with Unicode. So if you have, oops. Cafe spelled like that. Want to just make it back to cafe or something. That's another normalization trick. And the last one is just removing punctuations, because we also don't have that in our data set. Cool, so now we all put them together and call it preprocess and just go through all the steps and return the final text. So this is where the second part, this will be a bit shorter task, but so I want you to pick any one of these preprocessing steps and implement them for your particular bot. There might be, these are not exhaustive. There might be some very specific ones for your case maybe that you want to pick up that are not listed here, and that might be interesting for you to implement. So just one more or something, preprocessing step, and then add it to this function with that. So I'll take like 5 minutes for that, and then we'll move on to the next bit. Can't really see the Slack channel. Are things looking okay over there?
Yes, I think so. Looks good. We have one question. Couldn't ASCII normalization, like removing accents, etc., be problematic or detrimental even for some languages, or is it applied only for chatbot in languages that don't have accents and these things?
Yeah, it's a great question. Yeah, definitely. That can, depending on what your task is and what your setting is, and where it's being used, those accents can be important. But for us, it was good to remove them because first of all, we don't have them in our training set. So even if you use a model, the model can't pick it up, right? And certainly for our case, it can't because we're just doing exact match, right? But if you're using it for a language where these accents change meaning or something, then definitely you want to put them in. The setting for this particular task, we're thinking, okay, it's going to be used by English speakers at a hotel, and that's it. Yeah, that's sort of the scope of our problem. And of course, like if you don't do any normalization in your training data, then you maybe not want to do normalization during matching as well. So that also plays over.
We have another question where someone is asking if we could use other languages like Arabic or Persian, where we have right to left sequences.
I think it should, as long as it's a string and can be encoded into Unicode, I think there shouldn't be any problems. I haven't tried it, so I can't say for sure. There might be some other challenges, but there's probably like a lot of open source tools to deal with stuff like that. Like how the character is split or how the match is done, or converting them into like Unicode properly. There's probably some challenges around that, but it should be possible, yes. And of course, Tokenizer is different for every language.
And to the participant who asked the question, please try it out and let us know if it works.
Yeah,
what kind of tokenizer you're using, what kind of challenges you're running into. I feel like it's important to experiment with different languages. It would be cool to know.
Okay, I think I'll get started, get moving on with the next bit. And assume that you've implemented some kind of preprocessing step. And please, if it's something like unique to your task or something, or anything, just please share it on Slack so we know what kind of things people are writing. Okay, so we're good at this exact match bit. So now let's do something a bit more smarter. And we can use this library called Fuzzy Wuzzy, aptly named because it's doing fuzzy string matching, to get better at classification. And what it's doing, it's just looking at the Levenstein distance between two sequences. And that can be any sequences, or in our case, it's just the string. And looking at the difference between them, and if the score is high enough, so if they match closely enough, then return the proper intent. So you write a small function that does fuzzy matching with the intents, look at the matched query, and the score, and if the score is greater than 90, return the answer for that particular intent. And if not, just return I don't know again. So I didn't have like do in my training data, if I recall correctly. But if I do this, run this, whoops, it returns the right answer because it was a close enough match. So that way we just get a lot, all of a sudden we get a lot better from exact match rate. Even if I try something this complicated, like I definitely don't have this in my training set, but because the string matched properly on can I check in Earl probably up to here, it was a good enough match, so it returned the right intent and the right answer. But it kind of doesn't work. There's like, I mean, as you can imagine, there's a lot of drawbacks for this because if there's enough match, there could be overlapping intents, so you don't get the right one, right? So if I do what time is early check-in, it fails. It returned the wrong intent. It's thinking I'm just asking about checking when I'm asking about early check-in. And that probably happened because the distance was close enough to the list of matches for what time is check-in intent we had, then the matches for when is early check-in intent. And this just one word time wasn't enough to find the right one. So we're getting pretty good at classification now, but it'll still fail in a lot of things, right? Just like this one. So now it'd be good. Now we're at a point we want to have machine learning and have an algorithm that kind of learns from the data and makes good predictions.